Welcome everyone to my Intro to Python class. This class is intended for novice developers that are just getting into the field of programming. I chose Python as the language because I have found that this is actually one of the easiest languages to learn, but it also translates well into learning more advanced languages like such as C, C++. So it's a great programming language to learn to get started with, and I've got some reasons why, and we'll go over that here in our first video. The way I've got this class laid out, it is going to be a series of 10 classes. We'll start slow and build our way into understanding the fundamentals of Python, and we'll move through things like flow control, looping, look at some of the different data structures. We'll talk about breaking our code down into smaller things like such as functions. Maybe we'll group a bunch of functions together and create modules and see how those translate into code reuse. We'll move into file handling and error handling. We got to make sure that we can manage files on our system, getting data out of files. And then what happens when our code runs into some anomaly, right? Some error that we weren't expecting. Maybe our code is reaching out to the internet to pull some data and the internet is down. How do we make sure our code handles that gracefully and informs the user without causing a crash? So that's our error handling section. Then we get into some more advanced topics such as object-oriented programming. Object-oriented programming is a paradigm way that we write software. Now, Python is object-oriented as a programming language, but you can also write other types of programs inside Python, other scripting language type ways to writing code. So we'll look at object-oriented specifically on class 6. That leads us into some advanced data structures and how those can be leveraged. And then we'll talk about, we'll go back to working with the operating system with files and directories, but this time we're going to incorporate using the OS module and the shutil module to really add some functionality and features into our programs. We'll look at incorporating other libraries and packages that people have written that stand on the shoulders of giants. Somebody has already done something. Let's leverage that. If they're giving that available to the community, let's use their code and make our code that much easier to write and that much more functionality. And then we'll end with some utility where we can actually get some information off the web. It's called web scraping. And we'll look at some APIs, application programming interfaces. Allows our program to interface with other programs. For instance, if I want to create my own robot to tweet out messages on Twitter, there's an API where I can interface my application into Twitter to have my bot that I've developed actually write out and send tweets. So there's some really cool functionality you can do with APIs. All right, with that said, the way I normally teach classes is live and in person. This paradigm is going to be a little bit different for me. So the way I would like to do it is making sure that we're taking good breaks. I've broken every class into 4 subsections. So right now you're in class 1. We're going to talk about the Python programming language and its basic features. Then I want you to take a break. It could be a couple minutes. It could be a couple of days, whatever suits your needs. But I want you to stop focusing on Python, let your brain kind of digest what you just learned, and then come back to it a couple minutes later, half hour later, 15 minutes, whatever you need to reset your brain and come back in nice and refreshed to learn the next section. So you can do all of class 1 in one day. Each video is going to be 30 minutes to an hour or less. So that's my goal, is to make sure they're digestible chunks, and that way you can take breaks in between. I also like to ask a lot of questions in my classes to get that interaction. So I will pause and actually ask questions. What I'd like you to do is maybe pause the video, go find the answer, to make sure that you can do what I'm asking you to do, and then come back and I will kind of go over the answers after I ask the question. The last thing I'm going to ask of you is get your hands dirty. Play around. When I write some code, copy and redo what code that I'm writing. That'll get your hands on the keyboard. It gets you understanding and gets your brain wired to understand how applications actually work. It's one thing to see me write code. It's another thing for your fingers to actually type the code and see the results yourself. So spend that extra minute or a couple minutes and actually write some of the code. that being said, we're going to start slow, and we're actually not going to write code until we get to about the third section into our intro for class 1. This first class, what I want to do is I want to introduce to you a program called Jupyter Lab. Now, Jupyter Lab allows me to, in my browser, write code so I can execute it in a one line, execute it in a couple lines of code, and see the results right inside my browser. It's also really nice because I can take this code and send it over to a buddy, right? If they're wanting to write code, I've already written some of it, I can send it over to them and they can run it on their system. So Jupyter Lab is a great platform for writing code that's quick and easy and just a couple lines of code. And it's actually a really good platform to teach from because I can write code in my browser, and then I can also just click over different tabs and pull up more information for you all to kind of see what programming, what other resources are out there for programming. All right, so I've got 8 reasons why I like programming Python as our first language that you're going to learn. And if you've already learned another programming language, yes, you can still take this class and you'll probably get something out of it, hopefully, but it really is intended for somebody that's never written a program before. Now, go back to here real quick. Guido is the inventor of Python. He first released it back in 1991, and it's grown immensely since then. But I just wanted to give you the little bit of the history of when Python started and why we use it today. So can anybody tell me when Linux was first introduced to the world? When did Linus Torvalds and Richard Stallman release Linux to the broader community? Go ahead and pause the video and do a quick Google search. All right, welcome back. Let's look up Linux first released. And you'll notice that it's around the same time. So Python and Linux, although 2 totally different things, are contemporaries, right? They are around the same time when they were released. So that gives you a little bit of history of programming. Now, I'm going to also show you 2 other examples. I wrote them in a program called Visual Studio. Actually, I wrote this Hello World in 3 different. In fact, I gotta change it up to say Hello World. Oops, gotta spell it. Okay, so that's Hello World. Let's fix this one to just be Hello World once. And my C++. Let's put that up in the right order. Okay. So I've got 3 programs, all writing Hello World. Now, I don't want you to worry about the actual syntax at the moment. I just want you to know that this is 3 different programming languages, all doing the exact same thing. This is CPP, stands for C++. This is a very simple application that's just writing the word Hello World out to the screen. Now let's look at Hello World with .cs, which is C#. It's a little bit more readable. I mean, it's got, what, 14 lines of code to just write something out to the screen, but the 1 line of code that actually writes it out to the screen is pretty straightforward, right? Console.writeLine, and then we're writing Hello World. It's not necessarily perfect English, but at least you get the gist of what's going on, right? We know a console is your shell or your terminal that you're writing in. Writing a line, you understand what that is, and then we tell it what we're writing here. So while it's not perfect grammatically correct English, at least you can kind of read the line of code and understand what's going on. Now the most readable is our py file, our hello world3.py. Again, not perfect English, but it's 1 line of code, very simple, and it prints the word hello world. Now I know what you're thinking, print is going to print to my printer or something like that. That's not the case. The word print here is writing it out to the standard output, which happens to be a terminal window. So let's run this application, and I'll go ahead and run it. We'll just run it this way here. And I'm going to launch all 3 applications so you can see that all 3 produce the exact same result. You got to give it a minute because it's going to compile and build them. Okay, so you see the Python one takes the longest because we got to get the interpreter all set up. Okay, so I got 3 applications here. Let me kind of organize them a little better for us. Okay, so the first one is my C++. It compiled and created a nice executable called hello-world1.exe and lets me run it. Down here is my C#. It's got a nice hello world, and as soon as I hit enter, it closes. Same with my C++. And then my last one is Python. All 3 applications run great on my Windows computer. Now I am running Windows, and my intent is to teach this class assuming that you all have Windows. The nice thing about Python, though, it is cross-platform, so you can run it on other operating systems. So what I've got as an example of that is I've got my Kali Linux, which is a Linux distribution for pen testers. It's my favorite distribution out there. And I've got those, actually, we'll redo them. I'm going to copy them over just to show you how that works. So let's go over to my solution here and open up in File Explorer. There we go. So I've got my x64 file. We'll go to my debug directory, and you'll see that I have this hello-world1.exe. That's the file that we just ran. And I can copy that over to my Kali Linux. I can just make that full screen. Just going to drag that over, copy that there. Let's now go get our Hello World 2. And that's in my debug directory, net6, my Linux build. And I can grab this publish directory, which has all the files I need in it. And then let's go back and grab our Python. And the Python, since it's not compiled, we can actually grab the source code file. I'm going to grab the source code file and bring it over here. There we go. So now, for those of you that aren't familiar with virtualization, and what exactly is virtualization? Virtualization is an operating system inside using software. So I have my laptop is running Windows on it. I'm running an emulator that's emulating a second computer, and that second computer is running Kali Linux. So this is an entirely separate computer running inside of my primary computer of my laptop. It's great for testing because anything I break, I can just delete the single file that this Kali Linux is and then restart over, right? It's a great test platform. So if you're new to cybersecurity or new to software development, I highly recommend setting up something like VirtualBox or VMware and playing around using virtualization, because anytime you screw up, you can easily revert and undo, and it's like you never made the mistake to begin with. Okay, so I got these 3 files up here, or a folder and 2 files. One is the Python, one is the C++, and one is my C# that is built for Linux. Now what I want to show you with this example is that out of the box, I wrote that one Python script, Python, and I got to go to my desktop first, so that's what's going on. Python, and then hello world. You'll notice that right out of the box, no changes whatsoever. It prints out my hello world, right? Whatever my script was in Windows runs exactly the same inside Linux. Now, if I try to run hello world 1.exe, I gotta change it to make it executable. If I try to run it, got my cap locks on. You'll see that I get unable to run because there's no interpreter for it. If I actually run the file command on my hello world, you'll notice that it's specifically made for Microsoft Windows. So if I build it in Windows, it's really only good to run inside Windows. Python is a cross-platform, same application that I run in Windows, I can run in Linux natively. Now, there's a middle ground. that's where we're going to talk about our C#, and you'll notice that I was able to build it in Windows for Linux, and I can run it this way as well. So let's go into our publish directory. We can do an ls, and you can see that I have the hello world 2 there. So I got to change that one to be 2. Now if I run hello world, you'll actually see it prints out just fine. So what's going on here is I have 3 applications that I ported over from Windows into Linux. Now Python, because it's cross-platform, executes and runs no problem in Linux. Now it is an interpreted language, meaning that you have to install Python on both Windows and Kali Linux, but it's so ubiquitous that Python pretty much runs on everything. I've seen it run on Android phones, I've seen it run on Linux, on Mac, so it's pretty ubiquitous and runs everywhere. Now C# is kind of that middle ground. C#, when was C# first developed? That's a good question. Why don't we look up when C# was first released? Circa 2001, right? So this is right when I was in college. C# is actually the first programming language that I wouldn't say first. It's my favorite language by far. It came out when I was in college. I was learning Java at the time. So I started picking up C# because C# and Java are very similar. And then I just fell in love with the functionality that was available in the .NET framework. Right now, we're on .NET Framework 7, which 2001 we were on version 1. So we've gone a lot in terms of functionality over the last couple of years, but it is a great language. And the cool thing about it is that it is also cross-platform when you have an interpreter. So when I compile C++ code, it converts it from human typed in code, so source code, directly to machine code, instructions that the computer understands. The difference is that Windows understands different instructions than Linux understands, and Mac understands different instructions than even Linux. So if I build something for instructions that are specific to Windows, it's not going to run on instructions that are specific to Linux. There's a middle ground. C# is compiled, so it actually converts it to closer to that machine code, but it doesn't convert it all the way down to instructions that the operating system understands. It brings it down to instructions that an interpreter understands that is much closer to machine code. This allows us to have an interpreter for Windows, one for Mac, one for Linux, and then your code that you've compiled will run through the interpreter in real time on any one of those 3 platforms. The difference with Python also uses an interpreter, but it interprets directly from the source code. So if I go from C++ really fast, because I'm directly into the machine code, I can just start running it right away, with the caveat that I'm on the right platform. C# compiles it to an intermediate code that an interpreter can understand. So I get some of the speed benefits of compiling it down closer to machine code. I also get some of the benefits of, if I'm writing this application as a company, that if I don't want to give away my source code, I've obfuscated my source code down to machine code, so people can't just steal my code. And I get that speed, plus I get that cross-platform functionality. What I lose with Python is I actually have to give up my source code in order to run the application, and it also runs a little bit slower because it's directly interpreting it from human readable source code into the machine code in real time, so it's got to do that whole translation down into machine code depending on which platform you're running on. The negligence in speed these days, because processors run at 3+ gigahertz, is almost unnoticeable, right? If you're writing directly from source code, or you're writing from or reading instructions from machine code, the computer you can't even see the difference in terms of speed. So I would say that's not such a big deal with Python anymore. But the one big caveat why you don't see a lot more companies using Python is because the fact that you have to give away your source code for your application. So every Python application is open source because you run directly from the source code. All right, this is Visual Studio. This is a full-fledged, what we call integrated development environment. It's very complex, but we're going to talk much more about writing code in our Jupyter Lab. Jupyter Lab allows us to write right in our browser, quick 1-2 lines of code, and run them in real time right from our browser. A lot less overhead, a lot less functionality to have to learn. So that's why I prefer to write stuff inside Jupyter Lab. And in the next class, we'll talk about how we install Jupyter Lab. But for now, I just want to show you how easy it is to write code. And I'm going to use that print hello world example. And if I just click on this and I hit the little run icon, you'll see that it prints and runs right below this section of code. So this is a real quick and easy way to write code and see the results in real time right inside your web browser. There's another environment called PyCharm. This is kind of an intermediate between full-on Visual Studio, which is full-featured for lots of different programming language. This one is full-featured for Python, and Python specifically. So this language here really focuses on functionality for Python. So if I run my code here, instead of popping up that whole window and setting up a terminal, it's just going to run it right here below so I can see it in real time. And it allows me to write Python. So the way it works here is I have my Python, all my files, then I have the source code that I'm working on, and then I have this ability to run and write code. So let's just change it hello world. We'll say hello Jonathan, and then I'll hit run, and you'll see that it changes down there to my name down there. Okay, we'll talk way more about PyCharm here next section, but I just wanted you to see what that looks like. All right, back to our chart of why we think Python is the right language to learn as our first language. We've seen the readability aspect of it. We've seen how simple it is to write, just a couple lines of code, and I can teach you how to do that. We've seen the versatility, right? I can run it in, well, we'll talk about cross-platform in a minute, but I can run it in object-oriented, which we'll see that when we get into our class in night 6, I think, right? That's when we talk about object-oriented, night 6. Yeah, we'll talk about object-oriented functionality when we get there. But just so you get an understanding of what object-oriented programming is, it's just a different paradigm, a different way we look at writing code. We focus on things like nouns. When we write a paragraph, we have nouns and we have verbs. The verbs would typically be the things that the nouns can do, right? So if I'm a bus, I can drive, I can park, I can turn. So those, if we think of object-oriented programming, we would extract out an object of bus and give it the functionality of turning, of parking, of driving. And then we'd also give it the attributes of things like the color of the bus, how long is the bus, how many children can it handle, right? So object-oriented programming is just a paradigm way we look at how we're going to write our code. Most of the time, though, we're going to be focusing on what's called procedural code, where I just write instructions like baking a cake. First thing I want to do is add the sugar. The second thing I want to do is add the flour. Third thing I want to do, maybe I'll mix it up. So I'm going to write instructions one at a time. So if I think of writing instructions as baking a cake, that's how procedural programming works. We saw the cross-platform nature, right? So I can write a program in Windows. I can send that over email to my buddy that's running a Mac. He's on the web team. He's running his Mac computer, and he can run that same script on his computer without having to make any modifications. Then he can send that over to his buddy in the IT department that's running Linux, and that buddy can run it no problem as well. So the cross-platform capability is a really strong feature inside Python, and why I think it's so powerful to learn, because we get the ability to write our code once and use it everywhere. The fifth reason why I think Python is such a good programming language to start with is just the basic install of Python itself has so much functionality right out of the gate. I can do so many things with core, just standard install of Python, and show you the functionality without having to download anybody else's libraries or anybody else's code. And it's just so feature rich. Most other programming languages, you've got to build and use other people's libraries. Although, that being said, Python also has this huge ecosystem of third-party applications that you can use. You can stand on the shoulders of giants, right? Somebody's already written some code. There's no reason to reinvent the wheel. Go borrow that code if they're giving it to you for free. This open source community's got so much code that we can borrow and leverage. I'd actually like to show you an example of that. If I go into PyCharm, across the bottom you can see that there's a package section, and I can go to packages, and I can just look for ones of hundreds and thousands of packages, right? I can just scroll. Now this is even a whole list of them, right? This is just a subset. I can actually go to the internet and find a whole bunch more. One of my favorite ones when I'm just playing around is one called Faker. And Faker, when I click on it over here, if I make this big here, let's see if I can make this big. Faker is a Python package that's useful for generating fake data. Now I use this all the time when I'm writing applications just to get dummy data. I don't want to work with real operational data, users, actual birthdays and addresses and things like that. I want to work with fake data when I'm developing, get all the bugs worked out, and then when I move it over to production, that's when I will use the real data. That way your software developers don't have to worry about accidentally seeing employee and customer information that you don't want them to be able to see. With Faker, we can just use fake data. Here's how easy it is to install. I can use a pip installer, and that will actually install it for my distribution. Or I can hit the install button. I'm going to hit the install button here, and it actually will go to the internet, download this package for me, and make it available to work inside my Python environment. And then they give us some example code, right? I can just copy their example code. In fact, I'll do that right now. I'll copy some example code, put it on my clipboard with Control-C, and as soon as this finishes downloading, which I don't know how long it's going to take, I can go back to our section here, and I can actually run their fake code. And every time I run this, let's see if it's installed yet or not. Nope. Oh yeah, it did. Look at that. So it's finished installing. It gave us Michael Hall. If I run it again, it'll just give us another Colton Sullivan. So it's just giving us fake names. And I could do probably name. I don't even know. There's probably address. Let me see if I can put address in here. And I can get fake addresses, right? So this is a really useful tool when I'm developing forms and stuff where I want people to fill out fake information and see how my system works. So I can stand on the shoulders of giants and grab a bunch of their pre-developed applications and make my code, or my code leverage their stuff and makes my code easier to write, easier to understand, and give it a lot more functionality. Okay, number 7 is Python is an interpreted language, meaning that we don't actually compile it to the machine code. The Python program itself will convert it down to that machine code when it needs to run it in real time. What I mean by real time is as soon as I hit that play button right here, if I hit this play button, it's executing line 1, 2, and 3 back to back to back, and then gives me my result. So in real time does it actually convert this to the machine code. We saw C++ converts it all to the machine code up front. In fact, if I look at the code, where is my Linux? There it is. Log back in. Let's go to the desktop. And let's cat out. Cat is a command that lets us see the contents of a file. So let's look up Hello World 3. And you can see it tells us what's in that file, the instructions. If I do that same thing, Hello World 1, you see I get garbly-goop, right? This is the compiled data. It's got some metadata at the bottom, but you see that for the most part, it's got a lot of unrecognizable code and characters. The same thing happens if I go inside of our publish directory for our C# application. and I try to cat out hello world 2, not cd cat hello world 2, and you can see also there is unreadable code, right? If I look at, going back to our folder here real quick, where did I put the, I got to do it in Visual Studio, I think. Open up containing folder. If I look at Python for Hello World 1, I look at that CPP file, you'll see that it's about 1 kilobit in size, kilobyte in size. That is because it's rounding it. It really is way less than 1 kilobyte, but the bare minimum of a source code file is going to be 1 kilobyte. If you go look at the executable though, where I'm actually running the code, we'll look at the debug build, it's 65 kilobytes, which means it's no longer the default size of 1. It's got real instruction sets in there. If I go to our Python, because I'm running it right out of the code, it's 1 kilobit as well, and that's the source code and the program itself, right? So 1 kilobit is all I need. If I look at Hello World 2, which is our C# application, I go to the bin directory, I'll go to my debug. You'll see that the executable and the DLL, which it combines 2 together to make 1 application. The DLL itself is where the actual code is that it's running. This executable is a .NET executable that just tells it to call this DLL. So really, the code is only 5 kilobits. So looking at C++, we get 12 kilobits, C# we get 5, and in Python, it's only 1 kilobit. So we also save a little bit of space by running in things in Python. Okay, so where are we at on our chart here, right? So that's interpreted in nature, the fact that we don't actually build it, we actually run it every time from source code. The last and coolest feature of Python, that I think anyway, is what's called dynamic typing. Meaning that at the time of an assignment, the variable is given its data type. And we'll see data types in more detail when we get into section, where's data types? Yep, right here. So we're still going to learn it today, it's just going to be a little bit later today. So talk about data types here a little bit. Going to our C++ as our example. Let's create some variables and try to add different data types to them. So we're going to say int, which is short for integer. We're going to say I equals, I don't know, 9. So that's a statement. It's 1 line of code. But what if I want to change I to equal hello world? You'll notice, oops, I got a semicolon here in the statement. You'll notice that I get a squiggly line, which means that it's some kind of error. If I click on the error down here, you'll see that I cannot, in C++, take a constant char star and convert it to of type int. Once I've declared a variable of type int, it can only hold integers. In this case, hello world is what's called a char star or a string in C++. I can't assign anything that's not of the right data type that I initially assigned to I. So this gives me an error. Let's see how it looks in C#, and do I also get an error there? And I do get an error, and it's a different location, but it tells me the same kind of error, right? I cannot convert a string, which is a list of alphanumeric characters, to a type integer. Because I declared I to be an int, it can only hold numbers. Let's take the same code now over to Python and see how cool Python is. The first thing I want to point out, oops, I can get my code set up here, is Python doesn't have to declare a type at all. So I can get rid of this int keyword and just say I is equal to 9. Dynamically, what happens is Python says, okay, I know 9 is a number. Therefore, I'm going to give you I'm going to tell you you are of type integer. The next line of code, I say I is equal to hello world. Python says, okay, forget the fact that you're an integer before, now you are a string. So it dynamically changes the type based on whatever we assign to it with the equals operator. So that equal operator is our assignment operator, and dynamically it'll change to whatever data type is being assigned to it. Now, some people love that feature about Python, or love that feature about coding. Some people hate it because it can lead to errors. I'm on the fence. I like tightly typed languages like C#, but I also enjoy the flexibility of having a dynamic typed language like Python. So Python, and the reason why Guaido chose to do dynamic typing is it's much easier to read and it's much more intuitive to write. So dynamic typing is a nice feature of Python, in my opinion. All right, the other thing I'd like to point out, and we'll kind of close here, we'll do a summary and close out on this, but is Python, and the reason why it's so widely developed since 1991, widely adopted by so many people, is it's the flexibility of being able to work for data scientists. So I can do machine learning or generative AI like ChatGPT. I can write programs in Python for that. I could also write web development. So if I'm a web developer, I can write a lot of stuff in Python. If I'm a psychologist writing research papers and I'm doing a lot of statistics, I tend to use Python because it's just really convenient and easy to write statistic applications in Python without having too much of a learning curve. If I'm a full-on computer scientist writing large complex applications, a lot of times I use Python not in those large applications, but in my day job just to try something out real quick to see how it works, and then I convert that into something like a C++ or a C#, where I can get a little bit more granularity, a little bit more functionality, but I still get the quick and easy use of Python. So Python is a great programming language, first programming language to learn. You can also use it if you're in cybersecurity for automation or scripts to deploy patches to computers, to harden scripts. So very nice programming language to learn as your first programming language. With that, I'm going to tell you to take a break, go get something to eat, drink, relax for a couple minutes, let that kind of sink in, and then we'll come back. We're going to move on into getting Python installed on your computers and getting yourself up and running and being able to use Python. So I'll see you all in a few minutes.